Hello everyone, it's another year, another Valentine's Day. Now we are in the Valentine's Day year of 2012, the end of the world. I'm just kidding. Okay, first I want to wish everybody a happy Valentine. Okay, so as a quantum physicist, people often like to ask me what do I do as a quantum physicist, and in fact, what is quantum? And in that situation, I often like to take out a deck of cards. No, actually, excuse me. I don't mean a deck of cards, I mean a quantum system. When I say this is a quantum system, I mean there are many particles inside. So I know it looks like a deck of cards, it feels like a deck of cards, and even has many cards in the system, but this is not a deck of cards, okay? This is a quantum system. It has many particles in the quantum system, so first let me choose a random particle from the system, but randomly stick my finger into the system, like this. Keep in mind that if I stop 1 microsecond later, I will end up on this particle. If I stop 1 microsecond earlier, I will end up on this particle, but I stop on this particle, which is the particle we are going to use for this show. Remember this one. Okay. So, just to remind everyone, we are now in a quantum system, so we can no longer predict everything exactly. We can only talk about probability. Remember, the keyword is probability. Okay. Now, just to let you know, a quantum system has a quantum particle likes to be at a place of lower potential with a higher probability, and the higher probability and lower probability with a place of higher potential. So let me define this place with a lower potential and this place, this direction with a higher potential. So quantum, I know that's too complicated for you. So just remember, my particle always likes to be at this direction, which is the top. As I said, my particle likes to be at the top. That's right. Okay, let me try to disturb the system by doing some perturbation. Okay, I hope that's satisfying. And again, no matter how I disturb the system, my particle always has the greatest probability to be at the top. Even if I just do that, and you can clearly see that my particle is here. If you want to know why, you are basically saying you want to make an observation. So let's make an observation. Okay, let's put the particle somewhere here and put the rest of the system on the top. So, because this position has a lower potential, it has a highest probability to be here. And that's right, because this is a single particle. If it is here, it cannot be here. Okay, I know the system is kinda too big, so let me reduce the system a little bit, like this. Okay, let's take out 3 particles. 1, 2, 3. Okay. Again, my particle is in the middle of the system, and the system are all different. So, if it's in the middle of the system, how can it be at the top? But because of the probability, because of the potential, it always likes to be at the top. That's right. If I now do this again, it's again on the top. That's right. Okay. Let me reset the system. And now, of course, it's always on the top. Okay, that's the potential aspect about a quantum system. Another more interesting aspect is actually entanglement. So just remind everybody, when I choose a card, I use my finger to stick into the system. And when I do that, I create entanglement between my finger and my particle. Yes, let me give the system a little bit perturbation to disturb the system. Okay, one more time if you really want. That makes you happy. Okay, again. If I remember my finger has entanglement with my particle, so if I do this, this will be my particle. That's right. Okay. So the particle has entanglement with my finger. What if my finger now has entanglement with my mouth? That will be really interesting because that means my particle is now entangled with my mouth. So if my mouth now says a number, most likely my particle will go to the number. Let's try. Oh, looks like there's a 9 here. So how about I just use 9? Okay, let's try. 1, 2, 3, 4, 5, 6, 7. This is 8. The card after 8 is 9, of course. And that is entanglement. Okay. Entanglement is cool. But the greatest thing is that we don't know why. And in fact, nobody in this world really understands quantum mechanics, said Richard Feynman. So if you really want me to explain what happened, the best I can say is because of the wave-particle duality of this system. So when I say wave-particle duality, I mean when I observe a particle, it behaves just like a particle. It is here in the system, then it's nowhere else in the system. Okay. It is here in the system, nowhere else. But if I now stop observing the system, it's not going to behave like a wave. A wave that is everywhere in the system. A wave that is everywhere in the system. That is the greatest mystery of quantum mechanics. Happy Valentine. Love you.